Alright guys, here we go. Alright guys, welcome to a live forecast briefing discussion on this eve before our next severe weather event. I'm going to give everybody about 2 or 3 minutes or so to start piling in before I get started. Once I get started, I probably won't stop until the end, where we will have a brief Q&A for at least 5 to 10 minutes just to get some of these main questions out of the way as they come in. But definitely a somewhat potent event on tap for tomorrow. And we'll get into that shortly once we get some more people in here and everybody can get settled in. Alright, like I said, for the new people who just joined, giving them just a couple of minutes, 1 or 2 minutes for people to get in here and get settled. So we will start this forecast briefing shortly. If y'all could, go ahead and hit that thumbs up if you can hear me loud and clear, just to make sure there's no technical issues. You are welcome, Miss Audra Doris. Alright, like I said, for the new people filing in, I'm giving it probably another minute before we get started, but I'm letting people get in and get comfortable before we get into this live forecast briefing. Hope everybody's had a wonderful Monday afternoon. As good as a Monday can be. All right. Let's go ahead and get the basics out of the way. So today is Monday, March 3rd, 2025, and for tomorrow, March 4th, that'll be tomorrow, Tuesday evening, there is an enhanced 3 out of 5 risk, overall severe, for portions of the southern half of Mississippi. It's mainly focused on here all over the Mississippi River, eastern side of Louisiana and southwest Arkansas, but it extends all the way back into West Texas, far southeast Oklahoma, far northeast Texas, and goes all the way into the southwest portions of Alabama. And surrounding that, there is a 2%, so a 2 out of 5 risk for severe weather. For the rest of the portions of the state, that extends to most of the portions of Alabama, most of the rest of Arkansas, and at least the eastern portions of Oklahoma and Texas. And with this, we have a 10% hatch. This is going to be our most significant risk here for the possibility of maybe a strong tornado or two here in the portions of southern Mississippi south of the I-20 corridor. This is going to be your places like Jackson, Vicksburg, Meridian, and points south of there, as well as the northern portions of Louisiana. You got let's go ahead and get the population cities. So cities such as Shreveport, Alexandria, Greenville, you're right there on the edge, but we'll go ahead and include you. So the southern portions of Mississippi, northern portions of Louisiana, in that most favorable corridor for possibly a strong tornado or two. And surrounding that, you got your 5% that extends just a little bit further north. We're going to get into why that is here in a little bit. But the 5% extends, let's get some population cities. I'm trying to think what corridor that is. That's going to be like your Starkville corridor. Areas just north of Greenville. That's really your cutoff point. And it goes east into Alabama through Birmingham and points south through Tuscaloosa and points south. Southeast Oklahoma is in that 5%. And then the rest of Louisiana is basically encompassing this 5% as well. And a broad 2% low risk takes care of the rest of Mississippi, pretty much most of northern Alabama, northern Arkansas, southwest Missouri, eastern Kansas, eastern Oklahoma. So this is how your tornado risk is expected to evolve. It's going to evolve from west to east. Along with your tornado risk, you're going to have a damaging wind risk pretty much in the same exact corridor as your significant tornado risk. So if you go over, it's pretty much the same outlined area for your significant tornado risk and your significant wind risk. That's going to be your hatched black line right here. That stands for significant over here on the probabilities. So for tornadoes, that means EF2 plus is what we consider significant. And for wind, that is 30% plus is what we consider significant as far as the risk, and that's going to be wind gusts possibly up and over 70 miles per hour. Not as much of a hail risk, but we do have a broad 5% that basically encompasses the same areas in the southern half of the state as the other risks. So tornado, we have a 10 hatched, wind 30 hatched, 5% hail unhatched. So pretty potent day altogether. Look, I will get into questions. I see you guys over there commenting. What I'm going to do is I'm going to go ahead and get through the portions of the discussion first, and toward the end I'll have about a 10-15 minute section where I answer as many questions as I can rapid fire, especially with in regards to your specific area, so we can get a little bit of better clarity on who is in and who is out of this thing. But yeah, so your significant tornado risk is right here. Your mainly significant tornado risk. And there was a lot of talk coming into this event for the last, I would say, 5 days that this event could be particularly potent. A lot of, I guess you would call it, hype on social media. And from a long-range perspective, perhaps it did look that way coming into it. Now, this is still a significant risk by any stretch of the imagination, but it doesn't seem like this event is going to reach that high top-tier ceiling that we were originally afraid of looking at the long range. So, luckily, if anything, this event has downtrended from what its ceiling was, and we seem to have gotten at least a little bit lucky that we don't have a super high end, a moderate or high risk that could have been possible if things would have come together. So very lucky in that regard, but we still have a 10% hatched risk that we need to take seriously, especially if you live in these areas. And we're going to go ahead and get into the forecast discussion. So we're going to pull up the models. Here we're going to jump over to Pivotal Weather, and we're going to show you this monster of a trough or upper level storm system that's going to be working its way in. We'll give it a second to load. So this is the 500 millibar heights. These are winds ripping 25 to 30,000 feet above our heads. And this is really our main player for any significant severe weather event or weather event in general. It's how these winds interact with the eastern side of these mountains and create low pressure systems that create and draw up the moisture to be able to fuel these thunderstorms. You get your lift, you get storm initiation, you get instability, all from these upper level storm systems. So when it comes down to it, this is the most important part, at least in the forecasting process of forecasting a significant storm system. But as you can see, this is, let's go back a little bit. This is our main player, right? You can see the strong belt of flow coming to the lee side of the mountains over here, the mountain range. You got a strong upper level low that's already centered here in southeast Utah, and it's slowly ejecting east, and it's going to eventually eject over here in the eastern Oklahoma range. Now, when we were looking at this a couple of days ago, and even this is extremely impressive. When you're looking at these troughs and you're trying to at least have some idea of what's going to happen, you take this upper level low, and you draw a line through it, right? You can see it's a lot easier here because it's somewhat of an oval shape, but if you were to draw a line through the center of this oval, it would tilt to the right. We call this a negatively tilted trough. And negatively tilted troughs, especially with this strong a flow rounding the base and a strengthening, deepening low, is what you would typically look for these significant high-end tornado risks. Now, other things have to come together for that to happen, but synoptically, broad scale, right? When you see this a couple of days out, you start to get worried. Thankfully, there's some things that are limiting the higher end potential of this thing, but this look is quite an impressive look, I would say, especially from a modeled perspective. It'll be interesting to see it tomorrow on visible satellite. But with a strong belt of flow tilting negatively into the region, you get strong what's called difluence aloft. Where, not to get too scientific, but it's basically the spreading apart of these wind barbs right here. It's a little hard to tell if I can zoom in a little bit. Let me zoom in. There we go. But it's the spreading apart of these wind barbs. Sorry about that. There we go. And what divergence is, it's the spreading apart of these wind barbs, right? So this one is due southwest, streaking northeast, and this one is more out of the due west, slightly more easterly on the way it's pointed right here, and that's spreading apart. And what that does is it creates like a vacuum effect, and air from below wants to be pulled up to the upper levels to replace these winds that are spreading apart. And what that leads to is rising motion. You get your lift, thunderstorm lift. So if you have an unstable air mass here and you have instability, this can act as your forcing mechanism to drive storms upward. And when you have a look like this, you would expect really strongly forced storms up here in the difluence area. Now down here where you get a little bit more of a glancing blow to the forcing, it's not quite as strong on the divergence. You would expect to see maybe less vigorous forcing, less vigorous convection going up, and therefore the more prime opportunity for perhaps some more discrete development in the open warm sector, which would lead to your more significant severe weather threat. So just from the broad scale, you're looking at this thing, it checks as far as this particular parameter, as far as the 500 millibar heights map, as far as that parameter goes, this is pretty much textbook as far as significant severe weather. But where we get into the reasoning behind why this is not performing at such a high level, right? Your high-end events is because of this. This is your moisture, okay? This is your fuel. This is what fuels thunderstorm development in the open warm sector. Normally what you would want to see is, just for example, you would want to see this whole box I just drew filled with mid to upper 60s dew points for your high-end solution to verify with that kind of upper level trough. We do not have that. We do not have that whatsoever. Excuse this, let me get rid of that. But as you can see, how this warm sector is expected to evolve, you get kind of this triangular pinched shape, and there's some dry air on the eastern side of this that came from the storm system that came through yesterday. If you're in Mississippi, you might have noticed winds coming out of the north. That's cool air from the north kind of pushing these stronger dew points to the south. So we have a reservoir of just dry air sitting over here, making it hard for this trough to draw up moisture. And by the time we get to quote-unquote tornado time, right, the afternoon and evening of the severe weather event, when you have the hottest most unstable air going into the afternoon and evening, you just don't have that wide open warm sector. I mean, this is your quality moisture, right? This is not a lot. Scientifically, you need a lot more room for storms to be able to mature discreetly to have more of a significant and obvious tornado threat. So, luckily, this seems to be the limiting factor, especially for portions of northern Mississippi who have been cut out of this risk over the last couple of days, especially for portions, I'd say, north of, say, Tupelo and Oxford. The significant severe threat is not quite as favorable to those points north. Because the moisture is so far limited to the south, storms are not going to have the chance to mature and produce significant long-track tornadoes. Those are not going to be the case, especially to the north of the Oxford and Tupelo corridor where the moisture is just not present. Now, further to the south, right, into your Jackson, your Natchez corridor, it's slightly better. Let me see if I can zoom into a sector. Let's get into this. Alright. Why are we on the GFS? I want to be on the HER. So we zoom in. You can see how this little just triangle of moisture just surges northward as the Pacific front advances. And you do get intense moisture confined closer to the front, but over here it's just pinched, and this dry air is really just keeping this warm, moist air from advancing northward. So this triangle of moisture is your warm sector, right? If you're going to have significant severe weather, it would have to be in this little triangle. And as you progress it east, it only gets even more pinched. So, especially up here to the north, you see a little ribbon, but this isn't anywhere near deep enough to foster a long-lived, significant tornado environment. You'd want to see something wider like this down here to support that type of environment to the north, and you just don't have that. Now, could there be perhaps a brief spin-up tornado, maybe even one along the QLCS that might be slightly strong? Sure, that's definitely a possibility, but that's not currently forecasted given these parameters that we have in play right here. And it only becomes more pinched to the north and south of I-20. Even over here, you're only seeing 61, 62 dew points. Now that's okay to maintain a storm that's already ongoing, but it's not nowhere enough to foster continuous storm development. And these storms are going to need a while in the southeast to be able to produce those long-track significant tornadoes, and it's just going to be really hard given these factors at play. So your ribbon of moisture stays confined as it progresses east. It becomes a little bit more pinched, but you can see it's not quality. You're still sitting at 61, 62, some 63s, but if I were to draw the axis of the moisture, or at least the deep moisture, it's going to be right in here. And storms are only going to have this amount of time to be able to form, mature, produce tornadoes, sustain tornadoes, and these are going to be moving 60 miles per hour. 60 miles per hour, so they're going to be in and out of this warm sector. In fact, storms might already be out of the warm sector by this time. If we take a step at 0Z, this is 6 p.m., just to get an idea. Yeah, storms are nearly outrunning the warm sector by this time, and they're not very vigorous even at this point. So, especially farther east as we go overnight, it's not looking as significantly favorable for those long-lived, strong to intense tornadoes. The best odds of that are going to be earlier in the evening. As we go, let's go back to our dew points, go back to forecast loop. But this particular parameter, this dew point, our moisture return, is what's keeping this event from being a more significant event. Thankfully so. So if we go to 18Z, that's going to be noon. We get it's a little bit deeper and a little bit better here, at least on the HRRR. Farther west into central Louisiana. And then that same environment progresses through peak heating, 3 to 4 p.m., before eventually waning a little bit overnight. So that's why your best parameter space is said to be from here all the way over into southern Mississippi. Alright, so let's talk about another parameter. And then we'll get into the modeled evolution of what the precipitation could look like. So this is the 850 millibar height parameter space. So what the 850 millibar height is, it sits below the 500 millibar height pattern that we looked at earlier, right? So you have your 500 millibar winds moving up here, and you have your 850 millibar winds moving down here. So as far as tornadoes go, you see a strong increase of a southerly low-level jet going into Tuesday. And let's go to 18Z. The reason why we have such a intense tornado risk despite moisture, right? Despite the lack of good quality widespread moisture is this parameter right here. This is a 75 knot low level jet. That's at 18Z at noon. Let's fast forward it to 21Z. That's an 80 knot low level jet in the target area by mid-evening. What does that mean? Well, at 500 millibars, you have winds translating due west, from west to east, like this, right? Maybe a little bit southwest to southeast, but you get the point. Just like this. This is how these winds are moving. Lower at 850 millibars, you have winds out of the south, going due north. Strong winds going due north. What this does is this for any storm in the atmosphere, this is going to cause that storm to not only tilt but rotate. And with winds this intense, very high amounts of shear will be present at this time in the environment. Now, this means nothing if there's not a storm to take advantage of it, right? A mature storm by itself in the open warm sector has to be able to take advantage of this for it to produce tornadoes, perhaps strong. But if we were to get an individual storm in this environment that's mature, ready to go, it would probably produce an intense tornado. That's why the risk is outlined, because the moisture is it's kind of iffy, it's close. This right here, if you were to have that storm be able to mature, it would be bad news in this environment. Luckily, that's not the exact case shown by models, but it's close enough that we need to be aware for that scenario in case it does become a possibility. So this is very intense shear, not only directional shear, but speed shear. And we can see this if we go down to the HRRR, we go to the severe weather dynamics. And there's something we use to measure this amount of spin. It's called storm relative helicity. And that's just how much helical spin there is in the environment relative to what the storm is able to feel if a mature storm was in that environment, right? It's the perfect parameter to figure out how much a storm would spin. So let's fast forward it just to put it into perspective how intense this shear is. And it's an important concept of this event. So here's our target area. We are nearly off the chart as far as the level of shear that is present, low level shear that is in this environment. Just to clarify, it means nothing if there's a storm not there to take advantage of it. But at the higher end, right, you start getting to dangerous to intense around 250 to 300, right? That's considered an intense environment. Once you get to 400 to 500, that's a really intense environment. And then once you get up here, off the charts levels of low level shear, this is just at 15Z, and once it strengthens, you're getting values down here in the target area of 800 plus, right? very intense amounts of low-level shear. This is why there's such a high level risk as far as the 3 out of 5 enhanced for significant tornadoes, just in case a storm was able to take advantage of this. So, and that's going to be pretty consistent through the afternoon and evening. So, and you get this because of that strong negatively tilted upper level trough that creates this intense low level jet around the surface low. You get that extreme mass response ahead of this negatively tilted trough, and that's just textbook dynamics. For if this was late April and we had an open warm sector, this would probably lead to a high risk. That's the type of dynamics there is. But thankfully, we're in early March where there's not enough moisture. The moisture is struggling because of a cold, dry air intrusion from the night before, and we are really lucky that this is the case, because this could have been a really, really bad day. So, what we're all here looking for, right? What's it going to look like? Why, even though that these factors are in place, why is there not a higher risk? Well, as these storms, let's go to about 16Z, right? You have individual storms out here, okay? But they're moving so fast, and the low-level thermodynamics are so weak that they're not able to grow and mature on their own. There's scientific evidence to suggest that storms that fire in low-level thermodynamics like this need about 3 to 4 hours to mature, right? And you get storms that form, let's see, vigorous convection starts. Let's get a good accurate time frame. So these storms start to form roughly around 14Z, which is about 8 to 9 in the morning, and they keep going, moving 60 miles per hour due northeast in this poor low-level thermodynamic environment, and they're just not able to get there. Now, you get some that are close, right? Especially here in the southern Natchez, state line area around the Mississippi-Louisiana border. You get some maybe here up close to the Natchez and Jackson area, but it's just not enough. It's close, but no cigar. And eventually, what these storms are going to do, as they continue progressing east, is they are going to outrun the better moisture because they're moving so fast. As I said, if this was a wide open warm sector, if all of this was mid-60s and upper 60s dew points, we'd be looking at more of a problem. But that's just not the case. Your warm sector is sitting up just about like this. It's pinched off with northern exit, and as soon as they cross over that favorable moisture, the storms are going to become elevated, and they're going to come mainly, probably not even damaging wind producers, but just less severe. Once they exit the warm sector, they're not going to be as severe of a threat. So they get close, but no cigar, is basically the morality of the story, because of the modeled low-level thermodynamics. And that is thankfully the case. But just to be safe, the Storm Prediction Center decided it's a good idea to put out this 10% hatch for the majority of southern Mississippi, just in case one of these was able to latch onto the environment, mature, and possibly produce a tornado. It's better to be safe than sorry. I completely support that decision. With the dynamics that are in play, the low-level jet that's in play, you would rather have the risk out and have people take advantage of that opportunity to protect themselves just in case, rather than not put it out at all. So, as I said, right now, as far as the models are concerned, it looks close but no cigar. But if anything changes, if one of these or two of these are able to take advantage of the environment and maybe have the opportunity to produce a stronger tornado, it would be to the south of the I-20 corridor into this region to the southern Mississippi area if one of these individual storms were able to mature in this environment. So, not the worst of events. This isn't a worst case scenario, but it's definitely one, if you live in the area, you need to be looking out for. It's definitely something to keep an eye on the weather, stay by your warning source, have multiple ways to get warnings just in case. And let me see. And let's go over some timing. This is from the National Weather Service in Jackson. They do a wonderful job. And this is some timing graphics they've constructed to be able to give you an idea when these storms might reach you. For the west in the Vicksburg, the Greenville, the Cleveland, the Clarksdale area, this is going to be a noon to 4 p.m. type of event. You're going to get a couple of storms out in front, may or may not be severe. Then you'll have that line that pushes through, and then you're done. You'll be done with this event pretty quickly once you're in the area. As you can see, it's only a 4-hour window. If you are in the Yazoo City, the Jackson, the Brookhaven, Macomb, McGee, Kosciuszko, Greenwood, you're looking at 2 to 6 p.m. is your window when we're expecting these storms to get to you. Same thing up here in Oxford. But I can go ahead and tell you your significant tornado threat. I know I-20 is right here. I would not expect it to be north of this line. The significant, your significant long track tornado threat is not significant north of this line that I'm drawing right here. So if you are east, if you are in Columbus, Philadelphia, Meridian, Laurel, Hattiesburg, Poplarville, you're looking at 4 to 8 p.m. Luckily for this event, this is not going to run, at least for us in Mississippi, this is not going to run late into the overnight where you're going to have to be up all night watching the weather. This is not one of those. I will be chasing tomorrow. I'll be probably sitting down here in Vicksburg is my current plan, but I plan to chase this, get a good look at what they're doing. I plan on being in bed by midnight. And I live up here in northeast Mississippi. So hopefully this will be quick, in, out, nothing significant. That is the hope going into tomorrow. So that's as far as timing. And because those 850 millibar winds are ripping, you have that such strong low-level jet, some of those winds throughout the day are going to be transitioned from the mid-levels down to the surface. We call that gradient winds. And all over Mississippi, especially in the north, but you have a high wind warning here in the southern portions next to the coast, but up here in the north you have a wind advisory, and this is going to be for gradient winds up to possibly 30 to 40 miles per hour all the way up here into the northern portion of the state. Gradient winds were likely to be more intense up here to the north, probably Tupelo, Clarksdale, points north of there as that low-level jet ramps up closer to the surface low. So you'll get those 30-40 mile per hour non-thunderstorm winds just randomly gust throughout the morning, afternoon, and evening as that low-level jet ramps up. So be ready for that. If you got any trash cans laying around, I know it's our trash day tomorrow. We got to make sure we tie down that can, make sure we got anything that can fly away under control for those gradient winds that are going to be impacting us. All right. And finally, what we're going to do is we're going to end off, I'm trying to see what I want to do. We're going to end off with an analog. Okay. Now, sometimes I include analogs when I'm looking at an event, sometimes I don't. But when there's an analog as good as this one, I think it's worth mentioning as kind of what we could expect happening. And taking a look, this is your, what is that? Your area of low pressure, right? And this is going to be for February 24th, 2007. Okay? So you had your low in a similar place in northern Missouri, fairly deep low. And as far as your low-level jet, you had a similar really deep cyclone, and you had an extending low-level jet to the east. Perhaps we're a little bit stronger and more southerly with this one, but very similar concept. And then you have your 500 millibar trough that is negatively tilted. You can see if I were to draw the axis, it would look something like that. And then here's our event, this one. It's the same type of negative tilt and the same type of belt. We're a little bit stronger with this one on the belt of flow, but similar direction, right? Similar direction, similar belt of stronger flow rounding the base. And then this is our 500 millibar vorticity map, similar. Now we have a little bit stronger of a Pacific front here, but the location of this is pretty much the same. Okay, and what do we do with this? Similar concept, similar upper level pattern, similar moisture pattern. If we go to instability, similar pinched off warm sector right here. This is our instability. Let's take a look at moisture. Yeah, so you have your lower moisture down here. That's not good. I had something pulled up that made this easier. Is it this? Yeah. Okay, so this is the trough. Let's take a look at the dew point. There we go. Temperature, dew point, wind. Alright, so you can see how the evolution is very similar as you get this pinched off triangle-shaped warm sector that's interacting with this area in the same time frame that we're having our trough eject tomorrow. So it's a very good thing to look at when you get analogs this good, because it can give you a really good idea how that went. And so you can see the evolution, how you have that pinched off warm sector. Let's go 28. Yeah, you got your pinched off warm sector, and then you go to mesoanalysis and you have the same type of pinched off warm sector with very strong upper level, very similar. And let's see how that event performed. So let's go to severe weather reports. You had a widespread area of some damaging wind gusts, but you did have a couple of tornadoes here in the northern portion of the risk, and just 1 or 2 tornado reports in the open warm sector. Right? So not overly impactful event. It doesn't even tell me if these tornadoes, what they were rated or anything like that. But just very few tornado reports, but they were confined here. Now, if I was to compare this to our event tomorrow, I would probably take these reports and shift it south and west just a little bit, and maybe shift these south and west a little bit. But it's the same type of low-end environment that might produce some weak tornadoes, and on the off chance you might get 1 or 2 strong tornadoes. Less likely, but possible, and it's not going to be many. So this is sort of what could happen as this event unfolds tomorrow. Just using some pattern recognition, some analogs. Let's see. Trying to think if there's anything else I need to go into. Not only the Storm Prediction Center, they have their expert forecasting discussions down here, but another product we use is called the CSU, the Colorado State University Tornado Probability Forecast. This uses machine learning and AI. It's got a 10% hatched risk over here, or not even a hatch, just a 10% risk, with the 5% outlined in similar areas that the SPC has theirs outlined. So it's good to see some overlapping of confidence right there. And then if we were to go to SIPS, which is an analog base, so past base tornado events, and similar, it has a somewhat more favorable environment, but don't really worry about the percentages on these because they don't take account into some things. This is purely analog based, so it's not so much looking at what's going on now, but what's happened before. You have your favored corridor right here down into southern Mississippi, so it's good to get different ideas on what the risk could look like, what's the most favorable area. Just the more data, the better, right? The more things we can look at, the more things we can use to make a forecast, the better off we are and the more accurate we can be. So here I'm sure I have a lot of questions. I haven't looked at chat for a while. We're going to go ahead and end off this portion of just the overarching forecast. There's probably a lot of people commenting, asking, what about my location? What about my location? I will see if I can pull some specific ones to give you an idea what that could look like. We'll go to the HRRR, or at least the latest HRRR. We'll give you a look at reflectivity. And then I'll inject some context to where it's needed. But if 2 people ask about similar locations, I'll probably only do one of them just to, for the sake of time. I'm trying to keep this under about 10-15 minutes maybe of questions, but alright. So here we go. 21 viewers. Let's take a look. Alright. I know you commented a long time ago, Miss Desiree, but you are in Oxford terrified. That is okay. I completely understand how scary severe weather can be, especially if you've been impacted before. Oxford is right in this region right here, okay? I'm not going to say your significant tornado threat is 0, but it's really near 0. Your warm sector is way down here. I hope it eases your mind to know that it's very unlikely to see a significant tornado this far north in Oxford, okay? Now, could some damaging winds possibly still be ongoing for these storms that move out of the warm sector? You might get some gusty winds, some 60 plus mile per hour severe winds. That's a possibility. Maybe a brief, weak spin-up tornado is possible. Now, I can't tell you exactly for Oxford, but there might be 1 or 2 or 3 spin-up tornadoes anywhere along this line. You know, this is a large space to cover. So, 1 or 2 or 3 tornadoes anywhere along this line. You know, a tornado track is a relatively small slice of the land. And your odds are fairly low of getting hit by a tornado, especially a weak one, and have it do significant damage. So hopefully in Oxford, in that Oxford surrounding area, you can sleep a little bit better knowing on that. Let's see. Ready for some spring? Yeah, I feel you, Debbie. Let's see. You are in Amory, Mississippi, Tupelo, Saltillo. I'll go ahead and knock both of you out in the same basic corridor. So your Amory is going to be somewhere over here in eastern. What county is that? I don't remember what county that is. But near Tupelo, to the south of Tupelo, I believe, to the southeast of Tupelo. So over here in this region. Similar story as to Oxford. You're not going to have the moisture to be able to sustain long track intense tornadoes, per se, I should say. But there is a possibility you're right in this general vicinity. You're a little bit closer because these from the southwest are trying to move more northeast, but it's very likely that these will not be able to produce significant tornadoes. I would guess your major threat would be perhaps damaging winds over 60 miles per hour, and maybe a spin-up tornado or two because the low-level wind shear is just that intense along the line. Those would be your threats, and you should be done by 7 or 8 p.m. Let's take a look. Rolling Fork. Very good question. I visited there a couple of times last year. I absolutely love the area. Great people, great community. We just got our new tower cam up in Rolling Fork. And Rolling Fork is practically, I believe, right here in Sharkey County. Rolling Fork, the parameters are not as intense as the night that y'all got hit. I'll say that right now. The shear is, the low-level wind shear is, the moisture is not. There was a lot